Hey folks, today we're going to talk about temperature and thermal energy. The first question you might have is, what is thermal energy and temperature? Well, you should have learned about thermal energy before. It's the total amount of kinetic energy that's associated with the motion of particles in a substance. So if the particles are moving, which they should be, the amount of kinetic energy, or the energy due to motion that they have, that is the thermal energy. In most cases, the more thermal energy you have, the more movement or speed there is within the particles, and the higher temperature the substance is. Now, this doesn't count for phase changes or chemical reactions, but in most other instances, that is the case. Temperature is nothing more than a quantitative measurement, or a number, that tells us how hot or cold something is, and it is dependent on how fast the particles are moving. So, very basic concepts. When you have a higher temperature, the particles are moving faster. And if the particles are moving faster, they can move further away from each other, and that causes what we call thermal expansion. If they have a lower temperature, the particles are usually moving slower, and that causes a contraction, where the particles get closer together. Different substances can expand or contract at different rates, even though they're the same temperature. One good example is a bimetallic strip. If you take two metals with different expansion coefficients, in other words, they expand or contract at different rates based on the temperature, and you attach them together in a strip, as you heat it up, you might notice that it curves one way, or as you cool it down, you might notice that it curves the other way. We've learned about heat before also. It's a transfer of energy, specifically a transfer of thermal energy, or you could also think of it as a transfer of the kinetic energy of particles. So generally, when particles are moving at random, they tend to run into each other every once in a while. Those collisions transfer energy, and this transfer is what we call heat. You can transfer heat in three different ways. The first way is conduction, and that is where you come into direct contact with the substance that is transferring the energy. In other words, like if you place your hand on a hot stove, by touching it, that transfers the energy. Convection, which is where the energy is transferred by the motion of the molecules, so where the molecules move around and they transfer that energy with them. And radiation, which is energy transferred by electromagnetic waves, kind of like how you can feel the heat from a fire without touching it. There are three basic units of temperature. The first one is the one you're probably most familiar with. It's Fahrenheit. It was developed in 1714 by Gabriel Fahrenheit, a German physicist who was the first person to use a mercury thermometer. He chose the lowest temperature he could create in his lab, using water, salt, and ice to be the 0 point of his scale. For the other end of the scale, he used the temperature of the human body as 100 degrees. Eventually, the Fahrenheit scale was standardized so that the freezing point of water was 32 and the boiling point is 212. You may have heard of the second temperature scale. It's called Celsius. It's used a lot in science. In 1742, Anders Celsius, a Swedish astronomer, invented a temperature scale in which there was exactly 100 degrees between freezing and boiling. In 1948, the official scale of the metric system, which is what most scientists use and most of the world uses, was named the Celsius scale in his honor. Most countries use that scale. On the scale, water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. There's a third, much lesser known scale that we often use in particular science concepts, and it's called the Kelvin Scale. It was developed by Lord Kelvin in 1848 when he was only 24 years old. He was a British inventor and scientist born in Belfast, Northern Ireland. He sets the lowest point at 0, being absolute 0, which is the theoretical temperature at which all particle motion stops. Even the vibrations in a solid is no longer vibrating. All gases are now solids. Everything is condensed, and there's no motion whatsoever in any particles. It has the same size of unit as the Celsius scale, but the numbers just start at a much lower degree. So at 373 degrees Kelvin, that's the boiling temperature of water, which is 100 degrees Celsius. Water freezes at 273 Kelvin, which is 0 degrees Celsius, and absolute 0 is 0 degrees Kelvin, which is negative 273 degrees Celsius. There's a handful of equations you're going to have to learn to be able to convert between temperature units. The first one gets us from Celsius to Fahrenheit. And in that case, you take 9/5 of the Celsius degree that you have, and then add 32. To get from Fahrenheit to Celsius, you take your Fahrenheit temperature, subtract 32, and then multiply by 5/9. To get from Kelvin to Celsius, you just take away 273 from your Kelvin temperature. Or if you want to go from Celsius to Kelvin, you add 273. Okay, so let's try some example problems. The first one we're going to do is convert 59 degrees Fahrenheit to degrees Celsius. If we're looking for degrees Celsius, we're going to pick the equation that says C equals. So we do C equals 5/9 times our Fahrenheit temperature minus 32. Now we just plug and chug. 5/9 times 59 goes where the F is in the equation, minus 32. 59 minus 32 is 27. And when we take 5/9 times 27, we get 15 degrees Celsius. Now if we do the opposite of that, we could take 25 degrees Celsius, convert to Fahrenheit. That'll be our second example problem. So we're looking for degrees Fahrenheit. We'll take the F equals equation, which is 9/5 times our degrees Celsius, and then add 32. Then we just plug and chug. 9/5 times our 25 plus 32. 9/5 times 25 is 45 plus 32 gives us a final temperature, or a Fahrenheit temperature, of 77 degrees. Our last two examples are much easier. If we want to take 100 degrees Celsius and convert to Kelvin, we take the K equals C plus 273 equation, and we just plug and chug. You should get that the Celsius temperature of 100, or the boiling point of water, is 373 degrees Kelvin. For our last problem, we'll take 325 degrees Kelvin and convert to degrees Celsius. We'll use the equation C equals K minus 273. And then we just have 325 minus 273, which happens to be 52 degrees Celsius. At some point in your life, you may be asked to convert from degrees Fahrenheit to Kelvin. Well, you can't do that in one step. We don't have an equation for that. You would have to take your degrees Fahrenheit with what you know to go to degrees Celsius first, and then go to Kelvin. And the same thing would be true if you were trying to get from Kelvin to Fahrenheit. You would have to go to Celsius first and then back to Fahrenheit. You can't go straight from here to here at any point in time.